Welcome to the Control Engineering webcast, Why Open Source Works for Industrial IoT, sponsored by Influx Data. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you are having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speaker in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. Now we will hear from the sponsor of today's webcast, Influx Data. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation.
John is the Cloud Ops Manager for his company's SaaS offering. The system is being overwhelmed with all the metrics coming from the SaaS infrastructure, containers, applications, databases. It seems like it's coming at him from everywhere, and he needs to find a way to make sense of it across all these disparate sources. He needs a solution that can detect anomalies, provide insights, and let the business act in real time while it still matters. It needs to be able to handle the workloads which are growing exponentially, keep the customers happy, and help him ensure that the systems are performing at their peak. It needs to work with everything he already has, no rip and replace, and it needs to be easy to use, easy to change, easy to scale. It needs to provide the fastest time to awesome. That's not too much to ask, is it? He has already tried a bunch of different solutions, including traditional SaaS monitoring solutions, Cassandra, HBase, Elasticsearch, MySQL, and MongoDB, but none of them were built to solve John's problems. John doesn't have time to think about building his own time series database. Enter InfluxDB. InfluxDB Cloud was designed from the ground up to provide a highly scalable data ingestion and storage engine which is efficient at collecting, storing streams time-sensitive data, making it easy to query and visualize the data and send alerts all in a completely hosted, top-notch cloud environment. It allows for availability on demand and is kept up to date with a top-notch team of SREs, ensuring SLAs are met and systems are all functioning efficiently. Now John can focus on things that are important to his team instead of managing a time series database while still resting easy knowing he has access to a monitoring system, dashboarding engine, analytics service, and an event and metrics processor. With InfluxDB Cloud, John can sign up and be up and running in just a few minutes with access to all of the data he needs. If you're like John with more metrics and events data than you know what to do, try InfluxDB Cloud for free at www.influxdata.com/products/influxdb-cloud and find out how other customers like John have done to get more out of their data.
Now I'm happy to introduce today's distinguished speaker. Chris Torello is the Director of Product Marketing at Influx Data. She's responsible for product marketing. Prior to joining Influx Data, she defined and designed a software as a service monitoring solution at Centroid. And prior to that, she was Vice President of Product Management at iPass and was the line of business lead for several cloud services that required her to track the business and operational metrics and analytics to help identify and resolve issues. Chris, thank you so much for joining us, and please go ahead.
Thank you so much, Mark. I'm so honored to be here today. And a lot of you are probably wondering, why in the world does a time series database contributor like Influx Data, why should we be talking to you guys? And if you look at this slide, you can see that when you think about the data that a lot of your sensors are generating, whether it's a sensor that's on a machine, like a wind turbine, or it's on some machine that's generating whatever kind of widget in your factory, all those things are essentially what we call speaking time series data. And time series data is just really basically a value that is being tracked over time. So the number of blade rotations over a second, the amount of water pressure over a millisecond, the amount of whatever it is that you want to be monitoring over time so that you can make some adjustments to improve quality, to improve production, to ensure that equipment like these really expensive wind turbines are performing optimally and aren't going to break down because they're quite expensive. So all these sensors speak time series, and so that's why we're here talking to you guys, because we are the maintainers of an open source time series database. Now, the interesting thing about time series is, although fundamentally it's just a value and a timestamp, the context of how you, or what you're actually gathering is quite different based on the different kinds of use cases. So in that video that we looked at, the use case was really driving home the idea of being able to monitor your infrastructure, your apps, your containers, your VMs, et cetera. And that's kind of a DevOps kind of a use case. And if you think about all those things that the little character in our video was monitoring, those are things like the amount of disk that's being used, the amount of CPU load, how many bytes are going over whatever network. Those are all metrics that people gather to ensure that everything's working really well. And what's interesting is the resolution time for that kind of data is typically going to be measured in seconds or minutes. So how much disk I/O is being consumed in the last, second. And the other thing is you typically need that data, of course, in near real time, and then you want to be able to look at it in kind of the near future, because you're going to use that to gauge, how things are going in that moment in time if you do find something that's, not going as expected. But typically you don't need that level of granularity in this kind of data. And so people will often either aggregate it or downsample it, using, making sure that we can keep that kind of data for historical purposes so we can do some forecasting, but not necessarily needing that level of granularity for this kind of data. And the main goals are, making sure everything's performant, making sure that the user who's experiencing that application, whether on the web or a smartphone, is having a really great experience, and helping to see if you can detect if there's something that you can do to prevent a failure or prevent people having a bad experience. We all experience it. We experience it with even things like this webinar that we are all a part of today. Now, what's interesting in the IoT space is, yes, once again, we're measuring all kinds of different metrics, but very different kinds of metrics with also very different kinds of characteristics. IoT metrics are going to be things like temperature, pressure, flow, states of things. Is that valve on or off, right? These are the things that we want to measure in an industrial context that are going to help to make sure that whatever we're building, whether we have machines that are generating energy, we're building cookies in a factory, or anything that we're building, these are kinds of metrics that we need to understand so we can ensure that there's consistency of product or production, can ensure that there's a consistency for safety reasons as well. Also trying to identify areas where we can make some improvements so we can increase production or have production match demand, whether it goes up or down. But so the type of metric is a little bit different. But in addition to that, sometimes the resolution of the metrics are also drastically different. So in the industrial context, there are times when we need to actually go to the sub-second level. So resolutions at the minute level for things like water pressure may not show us any kind of a change and might not show us anything that's really happening in that moment in time. And so a lot of times we have to go to much more granular levels. The other thing is the retention policy for this kind of data is typically, 5, 10, 15, as long as you can keep that data with no downsampling. We want to keep that granularity for as long as we can, because that information that we're collecting can actually help us with understanding, can we, achieve our predictions, our forecasts? Can we do better? Is there something else that we can change? Also, it will also tell us things like, with this level of production, is there a possibility that some component of this machine is going to start to experience some kind of failure? So it's a totally different mentality and a totally different set of characteristics when we look at the two. Yes, they're both time series data, but what we're collecting as well as how and the characteristics are very, very, very different for both of these things. And I think it's really important that we articulate this, because people often think, oh, it's just, some metrics, what's the big deal? We know as we're collecting this stuff, it is a big deal. There are some key differences, can make a real big impact, good or bad, on what we're trying to achieve. This is not all the same. In addition, when I think about the industrial space, the challenges that are that everyone on this call is being faced with is totally different than what we see with in the kind of the DevOps space. Some things are the same. Like, everybody's going to say, hey, we need scale, we need speed, we need storage, we need lots and lots of different integration points, because we want to ultimately get to that point of being able to do real-time analysis with some really cool, AI or machine learning frameworks that are available to us, so we can get better at being able to understand, what could happen and how could we possibly improve that what could happen, what that outcome could be. But still, in doing that, there are still a lot of challenges with that, right? Where you collect that data could be all the way at the edge, right? If you think about the DevOps use case, some of it could be in the cloud, but typically a lot of these components are kind of put together. But the industrial context, these things could be way out in a field. You could have a bunch of solar panels that are out, way out, not really close to the humans that are managing those things. So the distributed nature of the architecture is going to be very, very different. In addition to that, there are going to be a lot more variances in architectures. Not everybody in the industrial world has adopted cloud. And it could be for security reasons, or it could be geographical reasons, right? If you're working in a hydroelectric dam, you might just not have really great internet connectivity, but still you need to make sure that the data within that location can move across seamlessly, right? And then, the other thing that's very, very different is I remind a lot of my colleagues that in this industrial context, we've been collecting data for years. 30 years, we've been collecting all this kind of time series data, which has been great, because there's been a lot of really cool things that it has been able to impact positively. But with that means that we have lots of legacy solutions that we have to still maintain, or we have to consider. We also have to consider, if we want to migrate them over, how do you make those kinds of migrations? So it's more than just like, hey, we want to go to this modern thing. It's like, hey, these old things, these legacy things were working, but how do we try to, enhance them with some of these new technologies? So a whole different set of challenges, I feel, that we need to consider in this industrial context. And there are a lot of systems that are out there that are claiming to be this incredible IoT platform. And the way that I look at these different platforms that are out there, and they're from all kinds of really great vendors, they have a tendency to focus on kind of the edge and what I call the hub. So on the edge, it could be that they're collecting data way, way, way out at the edge, all the way out the devices and the sensors. In some technologies, we actually see that because of that, they also include some gateways to be able to kind of manage all that traffic. But still, there's a focus on, collecting that information on the edge. And then on the kind of the central architecture side of it, we typically see that there's two different kinds of solutions that are out there. Some that are completely in a cloud under this kind of a hub idea, that's then taking that data that's being collected from the edge and then doing some kind of processing of it, some kind of transformation. And in some cases, what some of these cool solutions are also able to do is allow you to then take that data and to put it into your own enterprise applications that you've built that might be bespoke for your, really interesting and important industries. And I'm not going to argue, is it better to be way at the edge, have it more of a hub and spoke kind of architecture? To me, it's going to be up to what you need and also, where you think the strengths are a lot of those vendors. But the one thing that's interesting about any of those products is that regardless of, what architecture, fundamentally what they also have layered on top of it are these 4 different categories of services. So there's this data services level, so it's all about the collection and manipulation of the data. And of course, there's this very important security level, making sure that in some cases it's as simple as, are all those edge devices patched appropriately? Are the right level of controls put in place for those things so nothing malicious happens, right? They all tout a different type of security aspect to these solutions. The next level then is device management, right? So being able to understand where are those devices? What are some of the different components that are on there? When was the last time that component was updated? With what version of that component, right? Was it a component that was built 3 years ago or 6 months ago? Sometimes there's some variances. Managing that can be complex. And then finally, there's a level of connectivity, right? So, is it using just standard Wi-Fi or LoRa, or is it using some kind of 5G network? These things are distributed, so they all need to be able to communicate, to be able to send the right kind of information, whether it's data being sent up or patches being sent down. All that needs some level of connectivity. And so these different platforms that are out there, have these different kinds of capabilities that are tied to it. And once again, what you think is important for your infrastructure is going to be completely up to, the solutions that you guys have. But there is some commonality. And I have to say that the one big commonality that I've seen is that at the data services level, what's interesting is over 60% of the data that's actually being used at that data services level is this time series data, right? So there's definitely going to be some data about kind of the asset level kind of information about all those things. Also, when we last updated something or when the last time a technician took a look at those things. But it's really interesting that a lot of this data is actually going to be this timestamp and value, that metric data that I talked about, this time series data. And 62% is a lot of data to be looking at. And so we want to make sure that, you consider that and think about in those different platforms that you have, are they the most efficient at managing, collecting, storing, managing, transforming that time series data? Because it turns out that this data is actually really useful to you, because you can do all kinds of near real-time analytics on it so that you can then really help to inform the organization. Hey, are we performing okay? We can also build these really great visualizations with tools that are actually, allowing your management team, your operators, your engineers to be able to just, take a look at these things, whether on their laptop or on these great dashboards that might be, throughout the organization, to see the different levels of efficiencies that might have been achieved or might not, right? And also, you can then take, a lot of control back and start to make some really great decisions, or, start to think about other places that we can, make some optimization. So this data is really powerful, allows you to do a lot of different things, and really has a pretty significant impact on your organization. Okay, great. So you're like, whatever, yes, we've been dealing with this for years, Chris, but, we just use a MySQL database, or we just use some kind of, we have our big Oracle database, we're just fine. Or some of you might have said, hey, actually, that doesn't quite work for this kind of data. We still use it for maybe information about our orders. Maybe we even use a traditional ERP. But some of you have made the leap and said, hey, since the volume of that data is so significant, why don't we use some other tools or look at some other tools that might, help us to be able to handle that? And so a lot of times we'll see people that use things like a search database, like you can see here, Splunk, right? And the reason you might consider that is that it has a really amazing search capability that lets you go through all that data very, very quickly. And then a lot of other people have said, hey, big data, that became a thing a couple of years ago. Supposed to handle all this data, let's just dump it in there. But the thing about time series data is it has very specific characteristics. And so just for that kind of data, of course, I work at a time series company that is the maintainer of a time series database. So you're pricing it, of course, you're going to tout that a time series database makes sense. But it's important to consider those characteristics because you will have to develop capabilities in these other traditional data stores that are not native to them in order to make sure that it can handle this time series data in an efficient way. And so it doesn't really matter to me if you're not interested in InfluxDB. It is important to me for you to consider this type of a database for your projects. And there are many, many, many time series database solutions that are out there because it's going to make things a lot easier. It's going to make it so that you can really start to dig into this data and harness the possibilities of that data. So now I'm going to do the little plug here, and we'll talk about Influx data. And you may have heard of us or maybe not. Basically, as a company, we are the key maintainers of 4 open source projects. And so a lot of people are familiar with InfluxDB and don't realize that Influx data is actually tied to InfluxDB. So there's 4 open source projects. We have Telegraph, there's InfluxDB, we have Chronograph, and Capacitor, all open source. And InfluxDB in particular was built just for the purpose of time series data. And the things that we thought about when we were starting to build this is, if you think of time series data, the first thing is it always has a timestamp and it has a value. So let's just make sure it's indexed for time from the get-go, right? So you don't have to deal with that as you would if you were using a traditional data store. The second thing is, you want to make sure that we think about how you use this time series data, right? You want to make sure that depending on the granularity of the data, you may have a lot of data coming in at at various intervals, right? It could be at that sub-second, second, minute, whatever it is. You want to be able to handle a really high level of ingest of the data that's coming in. Because as it's coming in and you start to do the queries on that data, you might see things that are really important to you. And so you're going to want to be able to dig into that data really, really quickly. So you want to make sure, and so the cool thing about time series databases is that they do consider high ingest. That's the thing that they really focus on. And at the same time, handle high query, right? These are things that you would have to make modifications to traditional database to be able to, focus on. In addition to that, I mentioned that, you might have different retention policies or you might want to keep that data around forever. You want to make sure that those things are just configuration options and not things that you have to develop yourself in a traditional database. So whether you want to rapidly evict that data because you're like, I don't need it, at that second level, automatically just set it so the data that's coming in, it gives me a view, it does, it populates some kind of visualization. If nothing goes wrong, then start to downsample it or start to, get rid of some of that high precision data. But the other thing that you can also do is with time series databases, you can also then transform that data. And transformation can take the form of lots of different things. It could be maybe you want to throw it into a machine learning framework and apply whatever models that you rely on to try to make some predictions on what's happening. It could also be just merging basically different types of data sets. So a lot of times we see from a number of users, the data that they're collecting, they may merge it with things like really basic things like weather forecast, right? If you think of weather forecast, that's also time series data. So being able to merge those together can also have some pretty incredible insights. But there also may be other data from your ERP systems that have information about the orders that you're processing at that moment. So tying that together is going to make you guys really powerful and make you be able to really ensure that that you're actually doing things in your environment that's going to help with the demand of of your customers. So all this talk about all this data, the other thing about time series databases is that they also consider making sure that all that data just doesn't consume all the storage that you have. Time series databases also do a level of compression and compaction of the data, so that you can maintain it and you can use it very quickly. Be able to do these queries on that data without it having to gobble up, all of your infrastructure. And that's another thing that you would have to build if you're using some of those traditional resources. The other thing about time series data is that time series databases, that they're actually quite lightweight. So you can use it in a number of different architectures that you might have. You could literally use InfluxDB, actually all 4 projects, all the way at the edge. You can collect the data, do the processing there, and send that information, back to the devices or back into your main systems to use for forecasting purposes. You could have it all the data just coming into a central database. If that's what you prefer, you can do a mix and match. The applications themselves are really lightweight. Of course, the data that you collect, you'll have to, definitely want to, move them from the edge if you want to keep them in its high level of precision. But it's important for everyone to understand that these aren't, these databases are a set of developer tools that are meant to help you with whatever you're building. They're not like these very specialized products that you can only use in one way. These are meant to live under applications. They're meant to live with a bunch of different architectures. They're meant to live with being able to collect information via all kinds of different languages that you might be using with your projects, and all kinds of different ways of bringing that data in or taking that data out. Now, the cool thing about the data, as I mentioned in the very, very beginning, of sensors reading timestamp data, you can see on the right-hand example, I actually have an example of what it looks like when you're storing the data into InfluxDB. And we basically have 4 components. We have what we call a measurement name. So you want to just name this data set, give it something. And then you can actually add metadata onto it that might be really helpful for you when you're trying to group this data or trying to make sense of, this collection of data that's coming in. And we call that a tag set. And the field set is basically the values. So the water pressure value. That would be a field, and you can actually have a collection of values that you're collecting in this measurement. And then finally, of course, there's a timestamp. So looking at that structure, what you can see, what I've done at the bottom is I then just kind of mapped it to, a theoretical data set that you might be bringing in, where, you might have this measurement name be telemetry, and the tag set, the metadata that we're collecting. It could be, trying to help you understand, if you have a whole collection of different batteries that you might be using in your infrastructure. They might have different IDs. You can see I labeled one as product ID 1. And maybe there's also 2 different types of batteries. There's lead and lithium, or maybe there's a couple others. And then you can see, so that would be my metadata. And then you can see I'm also starting to collect the values of, the temperature, the current, and then I have my timestamp. So, there's a number of different types of data that's getting kind of mingled in here. And it could be that, this is a collection that's going to make sense for you when you're collecting, this data when you're in your particular infrastructure. So hopefully you're looking at that, you're like, yeah, that makes sense. I've seen that kind of data in our infrastructure, or that's exactly, the stuff that we're already collecting. So just focusing on that kind of data. And, this is just a kind of a really simplistic data architecture view that you might, to help you guys see how a lot of times we are fit into this industrial context. You have your sensors on the machines. Maybe the machines themselves are actually sending some kind of time series data, probably through some kind of a PLC or some kind of SCADA system. probably using all kinds of different kinds of protocols. I think most industrial contexts use OPC UA, Modbus, some kind of pub sub, or some kind of queuing solution like an MQTT. And then all those things can actually then just send that time series data into InfluxDB, regardless of where they're from, regardless of the different protocols that are being used. And that's because there's another project that we have called Telegraph. Telegraph is also an open source project of ours, and it's basically a collector agent, and you can use that to collect data, and it's going to format it, as I mentioned here, in this kind of what we call our line protocol, in this kind of a format. So you would put Telegraph on your edge devices if you want, or you can put it centrally, but it'll speak the various protocols that are available, take that data, put it into this line protocol, which then can feed it into InfluxDB. Now, the cool thing about Telegraph is that it's completely open source. We built maybe, I don't know, maybe a dozen of them as the maintainers. But then the open source community just took over. And we actually have over 250 different Telegraph plugins that are available, that are open sourced, that are available to anybody in the community. So when you take a look at the documentation, you'll see it ranges from things like an HTTP listener. It can be something very specific like a Redis database, or it can be MQTT. There's a wide range of different Telegraph plugins that are currently available. I already mentioned Modbus. There's RTI, which some people are using. It's kind of a pub sub that a kind of an open source kind of a consortium came up with that helps with a lot of this kind of industrial data. And you know, the person that wrote that one just took a look at Telegraph, thought, hey, this is pretty easy. I can actually map that to the structure of the data we're collecting, and boom, he actually created a Telegraph plugin and just makes it available to everybody. So you don't even have to go in and wait for our roadmap as Influx Data for this kind of a project. If you have some unique needs when it comes to data, you can actually either look and see if it's available, or reach out to the community and see if they have it, ask them to help build it, or you can even build it yourself. So pretty powerful, lightweight, and I think, you know, pretty useful when it comes to determining, you know, how you want to use this in your infrastructure. And then the nice thing about InfluxDB is that just by being an open source project, it's just open in nature. So it's not about just keeping that data there. You can also then throw this data into whatever you want to put in. If you have other, what you think may be more efficient data storage, you can put it in there. If you have other systems that can do all sorts of cool transformations, you can throw that in there. It's completely up to you. It's not locked down, and you don't have to ask us permission or pay us, you know, any money, because it's all open source, to be able to take that data and put it somewhere else. So I'm going to now review a couple of different use cases, and we have so many. And as a developer tool, you know, I think flexibility is just inherent, and then hopefully you can see that in these different case studies that that maybe it'll spark some inspiration with you, and maybe you'll take a look at this and see if you can, if you might want to use it within your own infrastructure. And in the industrial context, we have basically a couple of different ways that people are using InfluxDB. One is they may be selling some of those solutions themselves. So organizations like PTC actually have InfluxDB in their products in ThingWorx today. So you may be a customer of PTC and you are actually using InfluxDB under the covers. And so they just realize that, hey, they don't want to actually have to build that. They can, you know, just kind of put that underneath there and just rely on this technology and this vibrant community. Alternatively, we have some smaller organizations that are just building data historians, and they've come to realize that, hey, let's just take the time series portion out of it and throw InfluxDB underneath it. And then we also have a number of other cases where the team actually it relies on some of these solutions, but they'd realize, hey, I can actually pull out this time series data myself and use other open source projects like Grafana for dashboarding and be able to supplement the products that they're already purchasing from a number of these vendors. So I see lots of different ways in this industrial context on how people are using InfluxDB. We're not that solution that I talked about, in the beginning of, we're not managing those edge devices from a security or device management perspective. We're really just focused on that data services layer. And that's why we are often underneath these various solutions that our community is building and relying on. So in this particular use case, this one is actually a use case of a biomass energy producer. And they had actually a pretty old data historian that was being used, and they weren't utilizing it the way they probably should have. A lot of times, and you've probably heard this, a lot of times what they were doing was actually downloading the data and putting it into Excel spreadsheets, which, of course, the dangerous thing is the moment you download any kind of data that was near real time, it becomes very stale very quickly. And so that was kind of the habit that they had. They had their historical data, which was basically just data from 3 months ago, in some kind of a closet on some kind of a rack that was hidden, not available, not accessible to everybody. So somebody would go in, download that data, then they would do their analysis in a spreadsheet, which was very quickly outdated. And then they would share it in email or whatever means that they had to then, determine what they would do next. They actually worked with one of our vendors that has built a data historian, but also has a pretty strong consultative side as well. And so they worked with them to see, where they could use their existing solution a little bit better. And turned out that they made a lot of different improvements. The first thing being is that collecting all that data and not just storing it in some closet, but making it so that it's accessible to everybody via these Grafana dashboards was just a game changer for them. Nobody had to download stuff anymore. It was just there. They were able to give the management team and also the supervisors, access to these dashboards so that people could then start to, play around and see, like, what happened yesterday. Oh, what if I, change these queries and tie this data together? Are there other learnings that we can have? So they were super excited that they could be able to have access to that data. So they realized that, well, since it's open source, why don't we just go ahead and give this access to the operators themselves? Initially, they thought, yeah, those operators, they already have, the data coming in at the machines. They probably don't need this stuff. But it turns out a lot of the operators got very, very curious about this data because they understood how the machines actually worked, and they were starting to see the data from the entire organization. They started to really play around with this. And 2 people actually saw something that was a little bit funny in the data and were able to detect that one of the water tanks had a leak in it. It wasn't a very substantial leak, but it was something that they noticed by looking at the data. So they were able to inform the organization, and they were able to fix that. And it turned out, just by giving these dashboards to these operators, that leak was able to save them over $500,000. And so it wasn't what they were planning on doing, but they had a really wonderful outcome. Not only, did they save that money, but in the end, it also empowered those operators. They felt like they could really contribute to the organization by having easy access to this data. So another use case that we have is actually another energy producer, and they have a set of wind turbines. And the things that they were able to accomplish by being able to gather this data was not only having that centralized dashboard and being able to give everyone access, but you can remember I was talking about being able to tie additional data sources to this data they're collecting. That ended up being something that they really rely on quite a bit. So with this particular wind turbine case, they are actually based in Northern Europe. And so they do need to consider weather because when ice forms on the blades of the wind turbines, they need to shut down the wind turbines because it can be very dangerous for the wind turbines, and also because they're actually in a light industrial park. It could also be dangerous to anybody that might happen to be in the vicinity, which is fine. So they're happy to turn that off. They want everything to be safe. But when that happens, they also have to have, according to the legislation that they have to, or the regulations that said, they have to actually have a physical inspection. So they're also okay with doing that. But they started to think if they could just know beforehand when maybe the temperatures are going to potentially have ice form on these blades, maybe you can shut those wind turbines down before that actually happens. So then they could just avoid that inspection altogether, right? Don't even have the ice forming, just make sure everything is safe. And then when it's time again to be able to turn those back on, they can do that without trying to minimize the number of people that have to take a look at that. And so what they did was they actually added more sensors onto the blades that tracks temperature. They started getting forecast data, and then they marry those things together so that they can understand when they can proactively shut those wind turbines. And for them, it didn't stop at just that. They also realized that they can also predict the direction of the wind. That can also help them with understanding, if they have to make any changes. They also have to deal with if people are nearby, because there's something called shadow flicker that they have to be worried about. So when shadow flicker is happening, they have to turn these turbines off so that people don't get disturbed by that. And they can start to actually predict that because if they look at the angle of the sun, they can understand, when that could be an issue. And there's just even more really great use cases under this particular use case of how they're able to make those predictions with all this data that's now accessible to them. They were even able to make a digital twin of their setup so that they could not only get the numbers to be able to base those predictions, but they actually built a visualization that helped them to understand like what's actually going on, which really helped the entire organization. We have another use case of a really large offset printer offset printers, they have, huge, there's conveyor belts that are pushing paper all over the place. There's all kinds of different paperweights. These are things that are printing magazines and, really, things that need to have a lot of copies of something. So this isn't just like, going to your FedEx, Kinko's, your local copier just to make, 1,000 copies. These are making some really high quality print materials. And so print runs are going to vary depending on the customer and what the product is. Materials are going to vary, quantities are going to vary. The type of print, is it gloss or matte? They have so many different variables. And these guys were not taking advantage of the data, but they just viscerally knew that something wasn't right in their infrastructure, and they need to be able to start to rely on the data instead of what they actually called folklore. So a lot of the things that they were doing was based on, because somebody in the factory said, this is why we do these things. So an example was with these printers, you have the little jets that are using the various ink to make, to print the images, and you need to do some cleaning of these things. And there was this story that they relied on that said every 6 hours you have to clean them. But it wasn't really based on any data. And the moment that they were able to start to really collect the data to understand that actually, the cleaning is going to be based on the type of materials that this thing is printing on. If they have something that maybe doesn't require, as much consumption as these, maybe they don't have to do it every 6 hours. So they started to realize that by collecting that data, they could make decisions about the activity in the factory be a lot more, well, not based on folklore, and actually help them to make sure that things were, a lot more efficient. So they just went crazy and started collecting all this data. They actually had a situation where they thought they lost 800,000 tons of magenta ink And they knew nobody would take it. And what are you going to do with that much magenta ink? But they just couldn't understand why they had lost that ink. And by collecting this data, what they actually learned is that the counter that was counting how much ink was being used for every print run is mechanical. And what they hadn't realized is that mechanical things break. They know that in the rest of their organization, but they didn't think that they didn't consider that these counters over time could also be misrepresenting what's actually happening. And so they were able to do that by not just looking at the data, they just saw these tiny, tiny variances, and they decided, well, wait, why don't we throw that data into a machine learning framework and see if we can do some predictions. And sure enough, what happened when they applied these various models against that data, they could see that, oh, there's this weird vibration, this thing is going to break. And then they realized, hey, wait a minute, if this thing is going to break, how do we even know it's counting correctly? And so it really helped them to kind of look back and start to reevaluate, all the things that they have in their infrastructure. And then it turned out, of course, nobody took the ink. It just was a bad counter. They replaced it, and now things are a lot more accurate. And they know now they have to track everything in the infrastructure to ensure that it's running well. So that was kind of a fun use case that they had. And in this particular case, it was a set of consultants that came in that helped them to collect this data and build these really nice dashboards so they could start to work as a team to look at what are areas that they can have some more find some efficiencies. Other little things, they also collect information about how much energy is being consumed by every component in the factory. Seems obvious, wasn't obvious to them, and what they realized that when they shut certain components down, they didn't think about shutting down the electricity to the components that are attached to that main thing. And by being able to look at the data the energy that's being consumed with the data they collected, they realized, hey, we could actually save on energy costs if we, get a little bit smarter and shut things down. So they got really, really excited. And the funny thing about data is that the moment we start to find some really great things in the data, we get really, really excited and start getting even more inspired to dig in a lot more. And I think it's a really healthy thing. We all, people start to realize that, hey, it's not trying to corner somebody. It's just like, wow, look at this data. It's no more folklore. No, we're not picking on anybody. It's just like, hey, this is showing us, what's actually happening. And I'm just going to spend just a really quick time. So, these are just a couple of other architectures. This is actually from a company called RTI, and I think I misspoke earlier. The protocol that they developed is DDS. But, if you take a look at their case study, you can see this is this is an architecture that they typically rely on for healthcare. You have all kinds of devices that are with the patient in the rooms or in the wards. They are definitely tied to all kinds of different systems, whether it's, systems about the patient, systems about billing, systems about the inventory, because when you think of hospitals, they have a lot of things that they have to track, right? All the medication, all the tools, even things like gloves and, all the PPE, everything is inventory that they have to track, and they have to make sure that given the situation, they understand, they have enough of those things for what's about to happen. So lots and lots of data that they're collecting. And they were able to be able to create their solution so that they could also use InfluxDB with a totally different kind of an architecture in the autonomous vehicle sector, where they have these sensors on these cars. On the cars, there's all kinds of different data that they're collecting. They're also collecting all kinds of information from traffic information and trying to make sure that they could help to make these vehicles secure, and as far as when they're driving and making sure it's making smart decisions. So the great thing is, as a database tool or as a developer tool, these guys were able to make sure that it could really fit depending on the circumstances and not force them to kind of work the way we want to have them work. Developer tools are never going to succeed if they have that kind of a mentality. And I could go on. There's like so many different use cases that we have in this industrial context, and it's really, really fun. But I think we have about 10 minutes left. I do want to make sure that we open it up to some questions.
Great, Chris. Thank you so much. We do have some time for questions, and the audience may type questions in to the Ask a Question box on the screen, and we'll get to as many as time allows. Questions that we don't get to today will be posted online at controleng.com with the archived version of the webcast. Remember to download a certificate of completion or a copy of the presentation by using the Event Resources tab on the left side of your screen. And now on to the questions. So, Chris, does InfluxDB also provide the visualization of the data, or how would it feed to a third-party application?
Yep. So there's a couple of ways. One is we do have our own visualization tool called Chronograph. It's mostly used so that you can take a look at the data that's in the database, and there's some very simple dashboarding that you can also do. But I mentioned Grafana. Grafana is a really excellent open source dashboarding project that a lot of people use that. So you can throw it into that. In the industrial world, you might use Seek. That's another really great dashboarding capability. So there's a number of other dashboarding tools that you can use. But probably the most popular visualization that we actually have are the visualization that developers build themselves. So it could be maybe using some kind of like a JavaScript kind of a framework. You're building some kind of web application, and there's a specialized UI that you want to present, right? You can imagine like what RTI does for their hospital solution versus their autonomous vehicle solution. It's going to be totally different kinds of UI that they get to build themselves. And as a developer tool, we support all the popular languages that you might use to build these various UIs. We have users that have smartphone applications. We have, if you think about a number of the energy type of applications that are using InfluxDB, there's a couple of organizations that have provided a smartphone app that they would give to the, the operators that might go to, local instances of where the energy is actually being distributed. Then they also provide UI to all of us consumers as well. So there's one organization in Europe called eSoftings, and so if you're a consumer of the energy producer, then you can use this smartphone app that they've developed. Well, yeah, that they consumed from this company eSoftings. So you can actually see, what the energy of your house looks like with your smartphone. And then, we like to kind of threaten the kids in the house, stop leaving the lights on, stop playing this and that. The cool thing is this application actually can show the kids really quickly, hey, you shut the lights off. This is the impact it's going to have on our energy consumption. So all that are, being built by these various developers.
Great, thank you. With InfluxDB, are you also able to add geographic type data, latitude and longitude?
Yeah, you definitely can. The way that a number of our users have done it, and we have a set of Flux queries that allow you to do this, is we actually take advantage of the geohash, and that way you can be really smart with your queries. And a lot of different use cases for time series and location data. We have a number of users, community members that have built fleet management solutions, so they want to be able to track how well a vehicle is doing as it's moving. They want to understand location as well as the various time series data they collect. So they work very well together.
Is there a license restriction for using open source for industrial applications? How does that work?
Nope, it's all under the MIT license. And you can find that, just Google MIT license and you can see how open and unrestricted it is. It's really great. And the telegraph plugins are also under the same kind of a license. And we're starting to build out something called InfluxDB templates. And these are basically a dashboard, the telegraph configurations, also a couple of queries for the dashboards based off of community members' experiences. And that way you can kind of, get started a little faster. Those are also under MIT license, so open for everyone to use, whether it's in personal use or business use, it doesn't matter.
Great. Are there best practices to follow and technology to use to ensure that our data stays in-house when external processing or transfer is not needed?
Oh, yeah. I mean, the great thing, yeah, you can, there's a lot of different best practices, but yes, you can definitely, in most of these industrial contexts, well, first of all, a lot of times the actual networks are separate, right? So they actually keep the IT network separate from this, this kind of the industrial machine networks. Those are completely separate. A lot of times people are still doing a lot of things on-prem, so nothing's in the cloud. Yeah, I mean, there's however you want to deploy this, you can. Even if when I talk about deploying on the edge, it doesn't mean that it has to touch any of these outside networks. You can definitely just rely on kind of your closed networks to keep everything within your purview.
Thank you for addressing that. Cybersecurity is always a concern. Next question, are there any existing open source organizations such as Linux Foundation or Eclipse Foundation applicable and amendable for an open source project for industrial automation?
Oh, we love both of those organizations. We're great friends with the Eclipse Foundation, and they actually did a survey, I think 15 months ago, and that 62% number that I talked about was actually from them. They surveyed a number of their members to find out, what kind of data was actually being collected. And they have a lot of really great presentations that talk about it. They talk about, you take pictures of a lot of the components, so that's some of those data. Of course, the asset data I talked about, but it was in their findings that they shared with us that that 62% of the data collected was time series data. So yeah, we're all super fans of all these open source projects, and we do a lot with those organizations, and there's other organizations that we also work with as well.
Great, Chris. Maybe one more question before we wrap up, and I would encourage people to continue to type in their questions because we will try to get to them offline. But the last question, SQL like query, is it possible to do that? And then many existing reporting tools should be able to access data from InfluxDB.
Yeah, the query language that we have is called InfluxQL. We developed it because we wanted it to be easy. One of the things that we focus on as a developer tool is I think sometimes open source gets a bad reputation for being something you have to configure all day long, and then it's really tiresome and nobody wants to deal with it. And so our founder and CTO, Paul Dix, he was super impressed with a bunch of other technologies that allowed him to really get up and running in just a few minutes. And he always made it a personal mission of his to make sure that was the same with our open source projects. And so everyone says things are easy and quick, but try it. I mean, you can download the open source bits. You can also use our cloud version, which has a free forever tier, so you can see it. You can literally start collecting data from your laptop in just, a couple of minutes. A lot of people actually get started by collecting data from, all the stuff we have in the house. Like we can collect data from, our pool, from our thermostats, from, my goodness, if we just walk around the house, there's so many things that are emitting data that we can throw into a database. And so making sure that this is easy, quick, you don't want to waste time learning something new. That is really important to us. So I say just take a look at it and you can see. And the good thing is it's open source, doesn't cost you anything. And if we don't do our job, you can just go to a different project. So we really need to focus on making you guys successful.
Great. Well, thanks so much for the great questions, everybody. We'll try to get to as many offline as we can. And thanks again to our presenter, Chris Torello, for sharing time and expertise in this webcast. Now that we're nearly done, I'd like to extend special thanks to our sponsor, Influx Data, for sponsoring today's event. And we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. On behalf of Control Engineering and Influx Data, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.